So the next topic that we're covering is Pythagorean Theorem. So this is why we covered radicals before, because we're going to be simplifying in radical form, no more decimals. Okay. So here we have Pythagorean Theorem in a right triangle. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, so pretty much you do a squared plus b squared equals c squared. You guys have been doing this since middle school, elementary, so you guys got this. All right, so the Pythagorean theorem is used to find the length of one side of a right triangle when the other two are unknown. Find the length of the missing side. Write your answer in simplest radical form when applicable. So if we look here, we have this side is 6. Oh, there it goes again. This side is 6, this side is 8. Both of these are the legs, okay? These two sides that make the right angle, these are your legs of your hypotenuse. So those are the ones, that's your A and that's your B. So A and B. The order that you put A and B doesn't matter, okay? So we would do 6 squared plus 8 squared equals, and your hypotenuse is always the longest side. It's the side across from the right angle. So here's my right angle. Directly across from my right angle is your hypotenuse. We don't know what it is, so we're going to put it as c squared. All right, so 6 squared is 36. 8 squared is 64. This equals c squared. 36 plus 64 is 100. And then we go ahead and take the square root of 100. And we get 10 equals c. All right, moving on to the next one. All right, so the two legs that make the right angle, these are your legs. This is your A and your B. A and B. And then your C is always the side that's directly across from the right angle. That is my hypotenuse. All right, so then we set up our equation. We have A squared, which is 4 squared. B squared, we don't know, so we're going to leave it as B squared is equal to C squared, which is 6 squared, your hypotenuse squared. All right, so now we're going to start solving for B. So 4 squared gives us 16 plus b squared, we don't know, equals 6 squared is 36. Okay, we're solving for b, so I need to move this 16 over to the other side. And we get b squared equals 36 minus 16 gives us 20. And we go ahead and take the square root of 20. Now remember, we're not giving decimal answers. We're going to leave it in simplest radical form. So I'll just write here, simplest radical form. So we look for two numbers that multiply to give us 20. Remember, these numbers have to be a perfect square. Or one of the numbers has to be a perfect square. So you have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. I don't think we're going to have to go all the way up to there. But when we look at these numbers, we see which one of these is a factor of 20. Well, 4 is a factor of 20. So that means that 4 times 5 gives you 20. I have to move over my work over here. So b equals the square root of 4 times 5. Now we can take the square root of 4 and get a whole number. That gives us 2. So we're going to take that out. But we can't take the square root of 5 and get a whole number. So it stays trapped inside the square root. So that would be our answer. B equals 2 in the square root of 5. All right, the next one. Okay, remember you look for the two sides that make the right angle. So this is one side and this is the other side. Okay, those two are your legs. Those are your A and your B. So this is A, this is B. So A squared plus, we don't know what A is, so that's why I left it as A squared. B squared is the square root of 33 squared. Okay, equals C squared. C is your hypotenuse. It's your longest side. It is the side across your 90-degree angle. So this is going to be 7 squared. All right, so then from there, we have to simplify. So a squared is what we're looking for. The square root of 33 squared, the square root and the square cancel each other out. So we're just left with 33 equals 7 squared is 49. We go ahead and move the 33 to the other side by subtracting. And we get a squared equals 116. Yeah. And then we go ahead and take the square root. We can take the square root of 16 and get a whole number. That gives us 4. And that's it. That's our missing side is 4. All right, the next two. Okay. They give us a rectangle this time. So since they give us a rectangle, they tell us this is 7. That means that this side is also 7. Okay. Now these two are your legs, the two that form the right angle. Okay, so this is my A, this is my B. So 7 squared plus x squared equals c squared is your hypotenuse, your longest side. Remember, it's a side across your 90-degree angle, which is 12 squared. 7 squared gives you 49 plus x squared. That's what they put instead of b. They put an x there, so I went ahead and filled it in with the x. And then 12 squared is 144. Okay, I'm going to go ahead and move the 49 to the other side. And we get x squared equals 144 minus 49 is, let me see. 144 minus 40. Oh, sorry, because I want to make sure that I give you a crazy number. It gives you 95. So then going back to our perfect squares, we see when we take the square root to solve for x, the square root and the square cancel here, and we're just left with x. But we're going to see, do any of our perfect squares, are they any of them a factor? So I don't think they are, but let me just double check. So what you do, or what you can do, is divide 95 by all of those numbers to see if we can simplify it. Nope, none of those go in. So then that means that this one, since we're leaving it in simplest radical form, that's the simplest that we can get it. It's not going to get any simpler than that because the square root of 95 does not reduce. Okay, so that's it. All right, the next one. So here we have a trapezoid, and we are looking for this one that they're saying that is x, which is this whole thing right here. So let's go ahead and look at what we've been doing so far. So this is the two sides that make a right angle. Okay, that means that this is my A and this is my B. It's not writing. Oh, there it goes. A and B. And then if this side is a 90-degree angle, that means this side is also a 90-degree angle, which makes this one our hypotenuse, our C. So when we set this up, we don't know what A is, so I'm going to leave it as A squared plus, we know B squared is 5, so 5 squared equals our hypotenuse. Our hypotenuse is 6 squared. All right, so then from there, A squared plus 5 squared is 25, and 6 squared is 36. We subtract the 25 on both sides, and we get A squared equals 11. We take the square root. How do we get A equals the square root of 11? Now the square root of 11 we cannot simplify. It stops like that. So that means that this little piece from here to here is the square root of 11. And we're looking for x, which is the whole thing. Now if that's a square root of 11, then that means that from here to here is also the square root of 11. Okay, and we know that because they tell us these two sides are the same, which makes this the same as 6, and this is 5. Okay. Now the other piece of information that they give us is that from here to here is 7. So that means from here to here is 7. So now we can find x, which is this whole thing put together. So to find x, it is equal to the square root of 11 plus 7 plus the square root of 11. So we see the square root of 11 appear twice. That means we have 2 of those. That means we have 2 and the square root of 11 plus 7. And that's it. That's your answer for x, leaving it in simplest radical form. All right, the next one. So here it says, you have a garden in the shape of a right triangle with the dimensions shown. Find the perimeter of the garden. Okay, so when they ask you for the perimeter, that means that you are adding up all the sides. Okay, this is our perimeter. 88 plus whatever the side is, we don't know, plus whatever the side is, they tell us is 137. This angle right here, this is a right angle, so directly across from it is our hypotenuse. So this is our C. Okay, so then this is my A, this is my B. We don't know what B is, and that's my C. So you want us to find the perimeter? Well, first we're going to have to apply Pythagorean Theorem. So here we have 88 squared plus B squared, we don't know, equals C squared, which is 137 squared. All right. Then from there, we're going to go ahead and simplify this. So let me get my calculator really quick. All right, so 88 squared gives me 7,744 plus B squared equals 137 squared, which is 18,769. All right, we're going to move this 7,744 to the other side by subtracting it. Okay. And so that gives us 11,025. So B squared equals 11,025. So we go ahead and take the square root of both sides, and we get B equals. Now this one, let's see, gives us 105. So actually it gives us a whole number. We don't get a decimal here. So this one is 105. Now, if it did give me a decimal, I would still leave it as a decimal because in real world problems, you don't go to the store and buy 7 and the square root of 3 apples. It doesn't exist in those kind of things, okay? This just is for like exact answers and whatnot. But that's why we would round if we have to when it comes to real world problems only, all right? So now we found B, now we're ready to find the perimeter. So our perimeter here is equal to 88 plus 137 plus 105, and we add those all together, and that gives us 330. 330, our units are inches. This is not squared because it's not area, so this would be our answer. All right. The next one says you are going to plant a post every 15 inches around the garden's perimeter. How many posts do you need? Okay, so pretty much if I see, I start here, there's a post here, and then there's another one here every 15 inches. So we need to figure out how many posts do we need to buy. So you're going to take the 330 because that's all the way around, and we're going to divide it by 15. And that gives us 22 inches. All right. Then the last part says you plan to attach fencing to the post to enclose the garden. If each post costs $1.25 and each foot of fencing costs 70 cents, how much will it cost to enclose the garden? All right, so they want us to find how much it's going to cost us to enclose a garden. So C equals. Well, we're planning posts, okay? And we're planning posts. Oh, wait, this is not 22 inches. Sorry. I just noticed. We need 22 posts. Sorry. All right, so you need 22 posts. That's what we found in the last one. So we need 22 posts, and each post costs $1.25. They tell us right here. $1.25. Plus, we're going to need 70 cents for each foot of fencing. Okay, so we are going to take 70 cents, and we're going to multiply it times each foot of fencing. But before we do, if you notice our answer 330 inches, that was in inches, that was not in feet. So we know that there is 12 inches in a foot, right? So I'm going to go ahead and divide that by 12, and that's going to tell me how many feet I need. 27.5 feet. Okay, so the 70 cents, I'm going to multiply it times 27.5. I go ahead and put that in my calculator exactly the way I see it. So 22 times $1.25, because we need 22 posts and each one costs $1.25. Plus we're gonna need 27.5 feet of fencing, and each foot of fencing costs 70 cents. So that's gonna give us $46.75. So it's gonna be $46.75. Alrighty. Pythagorean triple. So a Pythagorean triple is any set of three positive integers, a, b, and c, such that a squared plus b squared equals c squared. So pretty much you get whole numbers. It works perfectly. So for example, here we have 3, 4, 5. This is a Pythagorean triple because 3 squared plus 4 squared gives you 5 squared. All right. And so 3 squared gives you 9, 16 is 4 squared, and 25 is 5 squared. So 9 plus 16 gives you 25. It means it works perfectly. So these are some examples of some Pythagorean triples. Okay, you can check them out if you want to see if they work, but 5 squared plus 12 squared is equal to 13 squared. Exactly, okay, there's no decimal. That's what a Pythagorean triple is. Now, by memorizing these, it would make it a lot easier for you guys to remember. So you wouldn't even have to show any work. You just remember here I have a 15 and a 17, then my triple here is going to be what? 8. So as long as you guys memorize these, it'll make it super simple to solve these, okay? So this next one, our Pythagorean triple, is a 5, 12, 13. And then this next one is 7, 24, 25. Now, the converse of Pythagorean theorem, is used to determine if a triangle is acute, right, or obtuse. So obviously, we know if a squared plus b squared is equal to c squared, then this is a right triangle, okay? But what happens if it's not equal, okay? What can we do if it's not equal? Well, okay, if c squared is greater than, then that means that you have an obtuse triangle. Okay, so greater than is going to be obtuse, and less than is going to be an acute triangle. So let's go ahead and try them out. So just by looking at the sides, of course, your c squared is your longest side. So if I look here, my longest side here is 9. Why does it keep doing that? 9. So I'm going to do 9 squared, and I'm going to leave a little blank here. Okay, I don't know what that is. And then we're going to do a squared, which is 7 squared plus 8 squared. All right, so real quick, I know that 9 squared gives me 81. Okay, we're looking for the sign right here in the middle. And then 7 squared plus 8 squared gives us 113. Okay, so then we're going to fill in the sign. Between 81 and 113, 81 is less than 113. So when you have less than, that means that you have an acute triangle. So this is going to be an acute triangle. All right, moving on to the next one. Remember, the longest side is your C. So in this case, 51 is going to be my C. So it's going to be 51 squared. We don't know what the sign is going to be in the middle. And then you take the two smaller sides, which are 24 squared plus 45 squared. All right, 51 squared, 51 squared gives us 2,601. We don't know the sign just yet. And then 24 squared plus 45 squared gives us 2,601. Well, these two are equal. So then that means that this is a right triangle, okay, because they are equal. All right, the next one. We have 13, 4, and 10. So we do the same thing. My biggest side is a 13, so we're going to do 13 squared. We're going to wait for that little sign that goes in the middle. And then our a squared, which is 4 squared plus 10 squared. 4 squared plus 10 squared is 116. And 13 squared is 169, I believe. But let me just double check. 169. All right, 169 is greater than 116. So when it is greater than, that means that we have an obtuse triangle. So it's going to be obtuse. And the last one, here we have 5, 12, and 4. We do the exact same thing. The biggest side is 12, so we do 12 squared. What is this? Well, I know 12 squared is 144, and we're going to look for the sign in between. And we're going to do a squared plus b squared, so 4 squared plus 5 squared. 4 squared plus 5 squared gives us 41. Well, 144 is greater than 41. Ooh, sorry, I just remembered something, but all right, 144 is greater than 41, so this would be considered an obtuse triangle as well. What I did forget, because it said determine if a triangle can be formed. Okay, that's what I figured out on this one. A triangle cannot be formed. Remember when you look at those two smaller legs, when you add them together, 5 plus 4, it does have to be greater than 9. So 5 plus 4 has to be greater than 12. But it's not, because 5 plus 4 gives you 9, and 9 is greater than 12. So this one's actually not a triangle. Not a triangle. Sorry, I forgot the first step where it told you to determine if you can form a triangle first. I believe the rest of them are triangles if we wanted to check. 24 plus 45. Is this greater than 51? And when you add them up together, they are 69 is greater than 51. So that means this one does form a triangle. We did this one, 7 plus 8, that has to be greater than 9, which this one also is going to be greater than 9. So it gives you 15. And then this one as well, 4 plus 10, that gives you 14, and 14 is greater than 13. All right, that's it for me for today. We'll see you guys next time. Bye.